Hi, and welcome to 11.2. This is instantaneous rates of change. Um, so in this section, there's really not much new, okay? We're going to be working with the derivative. We're actually going to be working with slope, okay? So if you remember the slope formula, um, keep that in mind. But what the main thing is that we're introducing here, or I guess the new thing, is really vocabulary, okay? And it's this word instantaneous, okay? And I'll tell you right now, the way we're going to find the instantaneous rate of change of the function at the given value is something we've already done before, okay? And it's going to be this f prime, the derivative of the function, um, at the given value, which is 1 here, right? So we're going to end up finding the derivative and then plugging in 1 to find the instantaneous rate of change, okay? And that's it. And we've done that before even. I think we actually first did that in 10.1. So not a lot new. What I did want to talk about, though, a little bit is this instantaneous. Where does that come from in terms of calculus, in terms of real world? Well, it does come from the definition of the derivative. Now, I drew this picture here, okay, and this is just a visual of the derivative, right? This is the tangent line to the function at point 1. So I'm actually going to be using exactly here at number 1, we're finding the given value of 1, right? So the derivative of the tangent line at the point 1, that's what this visual is saying, is just the derivative. Now, you might be looking down here and saying, what the heck is this? Well, this is the definition of the derivative, okay? But the variables are switched a little bit. Okay, I will tell you that s is position and t is time. So the change of position over the change of time is going to be the same thing as the derivative, where we're saying at time t, or 1, is the position of this function, right? Or the slope of the function at that time t. So I did just want to jot down too that that would mean that the y-axis here is position, or s, and the x-axis would be time t. Okay, so what we're really finding is the position of whatever it is, a car, boat, moving, in its position at time t, or its direction. Okay, so that's where this is really coming from. If you're going into engineering or what have you, into further math classes, that you might see when we're talking about instantaneous rate, or whoever's talking about it, your professor, that you're going to see that instead of the actual definition of derivative. Now, what we're going to be doing, though, obviously, is using that using the derivative to find the instantaneous rate at the given value, in this case, in number 1, at 1. Okay, so what I have set up here is just f prime of 1, right? So that's what we're going to be doing. What we need to do first, though, is obviously find the derivative. Now, we should set up, this is quotient rule, okay? So let's set up that quotient rule. So there's the setup of the quotient rule. Make sure you have that down. U prime times v minus u times v prime all over vv, or v squared. Okay, I'm just going to leave it as v squared down here, because we're just going to end up finding the rate at the given value of 1. So we're just going to plug in x, plug in 1 for x at some point here. But let's apply the derivative to where we need to. It looks like it's going to be 2x times x minus 3 minus x squared times, looks like the derivative of x minus 3 was just 1, so just x squared. Okay. And this is all over, of course, x minus 3 squared. Now, since we applied the quotient rule and the derivative, all we have to do now is just plug in our value of 1. Now, remember, when we do this, when we evaluate, we want to rewrite our notation. Okay, so I'm going to rewrite f prime of 1, right, because we're throwing that 1 in there. Now, what you really could do is just go straight into your calculator here and plug in 1 for each value of x. So I'm going to plug in 1 here, right, for x. I'm going to plug in 1 here for x. And you know what? I wanted black there, and it didn't switch. Okay. Minus 1 squared all over 1 minus 3 squared. So that's what we would plug into your calculator, right? And you can do this mental math however you want to do it, but you should get here negative 5 over 4. Okay, and we're just going to leave it as negative 5 over 4. Maybe you want to write it as instantaneous, just to denote that as instantaneous, and maybe box it like that. However you want to do it, because soon, later in these problems, we're going to be doing 2 different things within one problem, and it's nice to know which one is which. So instantaneous equals negative 5 over 4. Now, in terms of engineering, or in terms of, how you might see this later on in your math career, is there'll be units on here like meter square, right? So my position in meters, in my time in seconds. So meters per second here may be units, but we're just going to leave it as negative 5 over 4. Okay, so all we did, apply the derivative, and then plug in the value, the given value, to get the instantaneous rate. So let's move on to 2. And what we're going to do is make sure we adjust our notation here, right? Because we have y now. Okay, and we're gonna introduce a little bit more notation here. But so let's just find the derivative of y. So dy dx equals, well, it looks like this is negative 2x plus 2. Okay, now this is where that new notation comes in. Since we have the derivative done, what we're going to write is dy over dx, and then a slash down like that, a vertical slash, and x equals 2. Okay, so it's the same idea as writing f prime of x, which was 1 in number 1. But here we're now, since we're given y, we're writing dy dx. And to show that it's a function of x, we write x equals 2, and we're plugging in 2 to get the rate. So let's do that. Negative 2, and we're plugging into plus 2. Well, that's going to be negative 4 plus 2, or negative 2. So you can box negative 2. Again, you could write something like this to make sure it's the instantaneous rate. So either way, but there's your answer, negative 2. So it's that quick. Find the derivative, plug in the value. So let's go to 3. And it looks like we're dealing with y again. So we're gonna be writing dy dx again. Well, let's do that. And it looks like we're using the chain rule. Okay, so flash back to the chain rule. We're going to be using it here. Hopefully it's imprinted in your brain, because it's a great rule to use. And so let's apply the derivative here. It's going to be 3 times 2x squared minus x plus 1 to the second power times the derivative of the inside, or the inside of the parentheses, right? So 4x minus 1, okay? Now again, since we have the derivative, we can just plug in the given value and find that rate. Now I am going to rewrite our notation though, remember. We need to write this dy over dx at x equals 1 here, okay? And then let's plug everything in. So there's me plugging in 1 for x, right? And I wrote it in a different color just to show that that's where we're substituting 1 in, okay? And then, of course, you can type this entire thing into your calculator. Maybe you can't do that. Maybe you want to do mental math here. But what you should get, okay, is 36. So check that one out. See if you got it. Again, maybe you want to write it as instant, okay, equals 36. Instantaneous velocity equals 36. So there's the first 3, okay? So not much new besides the vocabulary, right? We're just taking the derivative and then finding the rate at the given value. Again, we're not even talking about position or time here. I'm not even saying at time, t, or time 1 second, 2 second, whatever it is. We're just plugging in the given value. So not much new here. And there's really not much new moving forward into number 4, 5 and 6, and so on. So what we're doing now is, for each problem, find the average rate of change of the function over the given interval. So the main idea here is, and I'm gonna make a visual over here to represent the average rate of change, right, is going to be this picture, okay? And again, same function as before, like I drew above. But now we're talking about an interval. In this interval, I use just x1 and x2, okay? Now, the difference here is the instantaneous rate of change was the tangent line, right, at one point on the function, or at one certain time on the function, right? But now we're talking about an interval. So the average rate of change between 2 points on the function, okay? And clearly the y values of these points, right, is going to be y2 and y1. So what we're really using here is just the slope formula. And I did mention this right in the beginning, right? There's not much new today. We're going to be using the slope formula here to find the average rate of change, okay? And I do want to say, too, it's kind of cool, like, the instantaneous rate was the tangent line to the function. In this case, since it's an interval and we're talking about 2 points in time, of the function or the position, it's the secant line that we're finding the slope of, not the tangent line, the secant line through these 2 points, okay? So let's go ahead and do that and apply it to number 4 here. And what I'm going to do, just to help me out, is just denote what x1 and x2 are here. Well, x1 is going to be -3, x2 is going to be -2. Now let's find y2 and y1, and then just plug it into that slope formula over here. Okay, so let's plug in, let's just do x1. So y is going to now equal 1 over -3 minus 2. Okay, well, that's -1/5. Okay, so there's y1. We have y1. And then let's get y2. Well, that's just going to be 1 over -2 minus 2, which is -1/4. Okay, so we have x1 and x2 and y1 and y2. Okay, now let's just throw it into our slope formula to find the average rate of change, right, of the function. So let's plug them in. So there's the setup. I just threw in y2 minus y1. Okay, see, check out this double negative here. So we are going to add those. And then down in the bottom, same deal. We have 2 negatives here for x2 minus x1. And again, you can always just type this straight into your calculator. But what you should get here is keep it in fraction form, and it's going to be -1 over 20. Okay, so that's your average rate of change. And again, we could denote it as average, and then equals, right, -1 over 20. So that's your answer there. Again, I just want to say there really isn't much new here. I mean, we're just using the slope formula here, and we're plugging in values. So nothing too crazy here. If you know the slope formula, boom, you're good. So let's move down to 5, and it's going to be the same thing, okay? Let's just write down what x1 and x2 are. So x1, x2. Okay, and then let's find y1 and y2. So y1 is going to equal here -1 squared plus 1, which is 1 plus 1, which is 2. Okay, so y1 is 2. And then let's find y2. Well, we're going to plug in 0. So 0 squared plus 1, well, that's just 1. Okay, now let's use the slope formula. So there you are. Maybe you want to do this type of thing like we did in the first one. The average rate of change equals that slope formula we just plugged in. right? Y1 minus Y2, or Y2 minus Y1, X2 minus X1. Well, this is just negative 1 over 1, which is just negative 1. So our average rate of change, number 5, is just negative 1. Okay? Hopefully that's getting quick for you guys. Again, just the slope formula. Nothing too crazy. So again, pause, rewind, fast forward if you need to. Okay? Otherwise, we'll keep going here. So now in 6, 7, and 8, we're actually doing the exact same thing. And let's just read this quick. Find the average rate of change of the function over the given interval, and also find the instantaneous rate of change at the leftmost value of the given interval. Well, I'll just hint real quick. The leftmost value of the interval here is going to be 0, right? Negative 2 here. You know, and then 1 down there. So that's what we're going to be plugging into our derivative once we get to solving for the instantaneous rate. So we really have 2 things to do. Find the average rate of change, and then find the instantaneous rate. Okay, so let's do that then. And the first thing we're going to do is find the average rate of change, which is exactly what we just did. Okay, so let's denote what x1 and x2 is. X1, x2. Let's find y1 and y2. So y1 is going to equal 1 minus our x1 term, which is 0 minus 2. Okay, well that equals negative 1/2. Okay, so y1 is negative 1/2. Y2 equals 1 over 1/2 minus 2. Okay, and that equals negative 3/2. Okay, so we have x1, x2, y1, y2. We can plug in to that slope formula. And I do want to mention one thing. You're probably wondering, oh, Mr. Fowler, what are you doing with this notation, right? I'm just writing it as y. Okay, well, again, since we're using the slope formula, we're just gonna notate f of x as y, right? It's just another way to write this, right? The function assigns x to another number y. Okay, so I guess we could write it as f of, well, since we're plugging in 0, we could write it as f of 0 here as well. But since we're actually just using the slope formula and getting y, we can just use y, okay? So just leave it as y, y1 here. Now let's plug into our slope formula. Okay, good thing I caught myself here. It's not negative 3 over 2 here. I forgot to put it over 1. So it is negative 3 over 2, but it's all over 1, right? So we have negative 1 over negative 3 over 2. Well, this is really negative 2 over 3, okay? Sorry, I didn't do that right away, but there you are, okay? So let's take all those values and plug them into the slope formula. Here's my slope formula. I kept going here a little bit, but right, these are going to switch to plus, minus a negative. Okay, so there's that plus sign I wrote in there. And then I also had to switch the denominators here, right? Because 3 and 2 we can't add. We have to change those to 6. So negative 4 over 6 plus 3 over 6 is going to allow us to get negative 1 over 6, okay? And again, we have to divide that by 1/2. Now, let's just do that down here. Negative 1/6 multiplied by the reciprocal of 1/2 would be 2 over 1, right? And that's going to be negative 2 over 6, or negative 1/3. So there's your average rate of change. Average is negative 1/3, okay? And what we now have to do is do the other one, which is the instantaneous, right? So we have to take the derivative and then plug in the leftmost value of the interval, which is 0 in this case. Okay, so plugging in is going to be nice, but we still got to get that derivative. So let's do that, okay? And what I'm going to notate it as is f prime. Okay, so f prime of 0 well, let's just do f prime first, right? Let's do f prime, and then in our last step, we'll plug in 0 for that x. So f prime of x is going to be equal to, let's set up the quotient rule, right? Again, that quotient rule is coming up. Stinks, but we got to do. I moved it over a little bit to have space. Again, u prime times v minus u times v prime all over v squared, or v times v or v squared. Now let's apply the derivative, and it looks like we're getting 0 here on that left term, minus 1 times 1, which is just 1, okay? And then this is all over that x minus 2 squared, okay? And this is going to equal negative 1 over x minus 2 squared. Now let's plug in our leftmost value of the given interval, which is 0. Okay, so this is where I'm going to rewrite our notation here. F prime of 0 equals negative 1 over 0 minus 2 squared. Now, you can do that in your calculator right away. I'm looking at that, and it looks like negative 1 over 4, and it is. So negative 1 over 4, and that is a squared here. Sorry. So your instantaneous then, if you want to denote it, instantaneous equals negative 1 over 4. Okay, so we got both of them, and we're done. And that's exactly what we're going to be doing in 7 and 8. Okay, so just increasing the number of things we have to do per problem, right? Nothing new here. So let's move into 7. Okay, and it looks like we're going to have to take the derivative of a quotient rule again at some point. But let's do this first. Let's find the average rate of change. Okay, so I'm going to just denote my values as x1 minus x2, or not minus, sorry, just x1, x2, right? And then we're going to be finding that y1 value. So let's find the y1, so negative 2 over negative 2 plus 3. Well, that's going to be negative 2 over 1, right, equals just negative 2. Okay, and then y2 is going to equal, now we got some fraction work, so negative 3 halves over negative 3 halves plus 3. Okay, well, let's maneuver this a little bit. Let's do negative 3 over 2 plus 3 in the denominator there. So rewrite the numerator. Well, that's going to be positive 3 halves. Okay, and I know that because I kind of converted that in decimal in my head. Negative 1.5 plus 3. Well, we're going half of 3 positive, or past 0. So it's positive 3 halves, or positive 1.5. And then we're going to multiply by the reciprocal right here. So 2 over 3. Well, if you check that out, these just all cancel. And I wanted red there. Oh, boy. I actually wanted red here. Looks like the 2's cancel, the 3's cancel. We're left over with negative 1. Okay, so let's take our values now, x1, x2, y1, y2, and plug them into the slope formula, okay, which is here, okay, y2 minus y1, x2 minus x1, and let's simplify this more. Okay, so negative 1 plus 2 is 1, negative 3 halves plus 2, okay, so negative 1.5 plus 2 would be positive 1 half, or positive 0.5. Let's just adjust this a little bit. We're going to multiply by the reciprocal here, and it looks like we're getting 2 for the average rate of change. Awesome. So there's the average rate of change. Now let's find the instantaneous rate of change. So we are going to denote this one, since it's y, remember, we're going to do y over dy over dx, okay, and then let's set up the quotient rule here. Okay, a lot to write here, but we got to do, here's that setup, okay, and let's take the derivative now of u and v. Okay, so it looks like we're just getting 0 there, so 0 in the first term minus, it looks like 1, okay. Derivative of x plus 3 is just 1, so 0 minus 1, and then we're going to leave it as x plus 3 down here, squared, or v times v, however you want to say it. And now we're going to include that new notation here when we're plugging in the given value, or the leftmost value, right? So the leftmost value is negative 2, so x equals negative 2 here. Oh boy, I forgot the equal sign there. So x equals -2, okay? And then this is now -1 over -2 plus 3 squared, okay? Okay, definitely made a mistake here. Derivative, I set up the derivative wrong, okay? And you probably noticed, so let's go back here a little bit. Now, in my u, I wrote 1, but now it's x, okay? So obviously u here is x. That's my mistake. And same with here, the u needs to be an x too, okay? Hopefully you didn't write too much further than I did, and hopefully you adjusted before I noticed. And so let's move in, right? And it's going to be 1 times x plus 3 minus x times 1, okay? And what we really can do is just plug in our value of -2 here, the leftmost value of the interval, right? And so you could take this and plug it in for all these x's, right? -2 here, -2 here, and -2 here. Or you could simplify the top a little bit, okay? But remember, when we write our notation, it's going to have to be in this form, right? dy over dx at the leftmost interval of x equals -2, okay? And what you should get is 3, okay? So instantaneous is 3 here. I'm going to box that. Okay, so we got both here in number 7, the average rate of change and the instantaneous rate of change. Make sure you go through this, okay? If you want to simplify, do it. Otherwise, plug into your calculator, okay? It's going to be 3. But take the time to do it, okay? Because I'm not going to work through the algebra here. So let's move into 8. And thankfully, it doesn't look like a quotient rule here, okay? So thankfully, it might be faster here to find the instantaneous rate of change. But first, let's find the average rate of change, okay? So let's find our y1 and our y2. I'm going to label these as x1, x2, okay? And so our y1 is going to be 2 times 1 squared minus 1 equals, it looks like 2 minus 1, which is just 1, okay? And then y2 is going to equal 2 over 3/2 squared minus 1. Now this looks like 3/2 squared is 9 over 4. Okay, so we could write that step. Let's just do it. Okay, minus 1. Well, this is going to be 18 over 4 minus 1, which is 18 over 4 minus 4 over 4, which is 14 over 4. Okay, well, that's a little gross, but we'll deal with it. Y2 is 14 over 4, y1 is just 1. So let's set that up in our slope formula, okay? And so here's our slope formula, right? And it looks like we're going to have to do 4 over 4 for our 1. Okay, so if you want to write it like that, do it. Okay, and then 14 minus 4 is 10. So we have 10 over 4. Over 3/2 minus 1 is just 1/2. Okay, let's multiply by the reciprocal. Okay, and it looks like we're getting 20 over 4, which is really 5. Okay, so our average rate of change here is just 5. Okay, so I guess it wasn't that long. Let's move into the instantaneous rate of change, which we're taking the derivative first, right? And what do we have here for our notation? We have f of x. Okay, so let's do this in green. We're going to find the derivative of 2x squared. What was it? 2x squared minus 1? Yep, 2x squared minus 1. Okay, so that's going to be 4x, and it looks like that's it. Okay, so I am also going to add this notation. We have to find the leftmost value of the interval, which is 1. Okay, so put in 1 there. We're assigning 1 to, it looks like 4 times 1, which is easy enough, and we get 4 here. So the instantaneous here number, what number is this? Number 8? Yeah, number 8 is then 4. Okay, so both of our steps are done there. We found the average rate of change and instantaneous rate of change, and there you have it. So hopefully this went well for you. Sorry about that mistake here in number 7. Hopefully you caught it. Okay, I just plugged in wrong here. Um, um, you go speedy and you just forget things. But no worries. This is right at 30 minutes, so we made good time. Again, let us know if you have any questions. Myself, Miss Vasquez, Miss Weedoff, we're here for you guys always. And again, always feel free to fast forward, rewind, pause if I'm going too fast. Okay, and we'll see you next time later on in the unit. So thanks.